All right, so good evening once again, guys. So we would have started looking at factorization from the previous class. And so we are continuing on this topic. So I'm just going to briefly recap what we would have done last class. The list, objective list here, and when we refer to objective in any subject at all, their objectives are tasks that you should be able to do as a student. So you should be able to list the types of factorization technique. You should be able to determine the HCF for a set of algebraic terms. You should be able to factorize expression by HCF techniques. You should be able to factorize four-term expressions by grouping. And in addition to that, did not mention here, but you're supposed to be able to factorize quadratic expressions as well. So these are the different factorization type techniques that we will be looking at throughout this topic. So we have factorization by common factor, which refers to as the HCF method. We have factorization by grouping, which also we use the HCF method. Then we have quadratic expression. Then we have kind of about 2 or so techniques in that. So we have the AC method, which is commonly practiced. So we are going to learn that method, and maybe I'll teach you another method depending on how well you are doing this method. All right, so we have perfect squares, and this is done by a method of inspection. All of that will become clearer when we are going through them. We have difference of square, and this will be done by a formula. And here we have some expression containing or consisting of 5 terms or some 4 terms. Now, for these, we will do kind of a integration of various of the above methods that already been mentioned. All right. As I said, we started off looking at the HCF method. And the HCF method is simply just to find the highest common factor of some terms in the expression. Now, I would have explained the concept of factorization and what it is that we're really doing when we are factorizing. And in a previous class, we would have looked at removing brackets. And we know that if we're removing brackets, we apply the distributive law, which states that multiplication of so the multiplication of a group of number is distributive, or the multiplication of a number is distributive over a group of number that are added or subtracted, right? And that's what distributive law actually refers to. And we would have seen that when we remove brackets, we are actually multiplying out what is inside the bracket by what is outside. Now, just to recap, anybody remember what a factor is? When we talk about factor, anybody remember what factors are? Can somebody just give me in your own word what you think factors are? May I, let me ask Miss Amanda, what are factors? Miss Amanda, are you there? Miss Cavero, would you like to answer that question for us?
No, sir.
Ms. Waysom, can you answer that question for us?
Sorry, asking what is a factor?
Yeah, our factors in general, what are they?
Numbers when multiplied, sir, gives you a product. So factors would have been the numbers that we use to multiply to get a product.
All right, correct. So we multiply two or more numbers to get the results of what we refer to as a product. The numbers being multiplied are referred to as factors. So for instance, if we multiply 3 times 2 to get 6, the 3 and the 2 there that we multiply, those would be factors of 6. Now, another way to think of factors, a factor of a number is that number which can go in, is a number that can go into the second number without a remainder, right? So 3 is a factor of 6 because 3 can go into 6 without a remainder. 2 is a factor of 6 because 2 can go into 6 without a remainder. 1 is a factor of 6 because 1 can go into 6 without a remainder. And 6 is a factor of itself because 6 can go into itself without a remainder. And so those are what we refer to as factors. Now, factorization is in algebra. We are not really referring so much to numbers, but we're dealing more so with expressions. Now, when we remove brackets, and just to review what that is. So if we have, say, for instance, 3 brackets, x plus y, and we are to remove this bracket, what would we do? What we do here is to do what? Anybody can tell us what to do here? Somebody quickly just walk me through how.
Carry out the distributive law, sir, by using what is outside of the bracket to multiply what is inside the bracket.
And what we would get from this after
3x plus 3y, sir.
So we'll get 3x plus 3y. And I hope everybody understands how to get this. All right, now, the fact that we use 3 to multiply the brackets or to multiply the entire group of things in the brackets, then what we're really doing, we are multiplying. So 3 itself would be a factor. And the entire group, which is the bracket, would also be a factor because you're multiplying 2 things. You're multiplying 2 by the expression in the bracket. So when we multiply the brackets, what we get on the right-hand side is our product. All right. Now, when we remove bracket, we say that we are expanding. And so the result will be the product of what is being multiplied on the left. Now, to factorize would simply mean to reverse this process. So if we are given the product, how can we write back this so that we get back it in the form as factors, right? That's what we're doing. And so in a similar sense to numbers, if we have 2 times 3 give us 6. Let me use a different number. So let me say, if we have 12 as a number, and I say to factorize 12, what it means is that we want to find numbers that we can multiply together to give you 12. Give me some example of some numbers that we could multiply together to give you 12.
2 and 6, sir.
So you could use 2 and 6.
1 and 12.
And so 2 and 6 here could be written as 2 and 6 here would be written as 2 times 6. And 2 times 6, we know that that would be equal to 12. But what we have on the right-hand side would be factors multiplying together to get 12. So these would be example of factorizing 12. So to factorize 12, we write it as the product of two factors, 2 and 6. We could use other factors of 12, like 3 times 4. So we could write we could factorize 12 into 3 times 4. Now, as I said, when we're doing that in terms of expression, it's a little bit more complex than what we're looking at here. So it's not as straightforward as a number, but using this should bring out the idea what we mean by factorization. So if you're given an expression, you want to write it back in a form where you're either multiplying a number times a bracket or multiplying a bracket times another bracket. That process of reversing an expression into factors is what we call factorization. If you are clear on what I've just explained in terms of factorization. All right, it seems like we're still not clear yet. All right, so if we look at this expression where we have 3x plus y, what do to the 3x plus 3y, 3x plus 3y, what can we do to this expression so we can get it back as 3 bracket x plus y? We have to look at each term in the expression. Look to see if you see any number and letters that are common within the terms. So here we have common to both terms. So it means that we call that a common factor. When we're factorizing, we generally first identify the common factor. Once you identify the common factor, we pull that common factor. And then now, so we try to identify all the common factors. So here we only have 3. We have 3 as a common factor. So we pull out 3 as the common factor. And then we open our brackets. This 3 to divide each of these terms. So 3x divided by 3. The 3 would cancel, leaving x. So we put x in the brackets. So whatever we get when we divide, the result in the bracket. So we keep the sign in the expression. So 3 divided by 3, cancel out, leave y. So notice here, after we have done that, we would have written back this expression in the form of factors. So one factor here would be 3. The other factor here would be the expression, entire expression.
Yeah, write out the factor, the instruction we might get, the example of it.
All right. Got a question, Miss Amanda? All right. All right, so that's the idea behind factorization. However, as I had mentioned before, they won't all be as straightforward as what we have just looked at. That is the simplest form you would probably see when you're doing any form of factorization. So to kind of dig a little deeper, remember we say that we have various types of expressions. Now, each of these expressions here, we would require maybe a different approach. So the ones that we use, common factor, the HCF method, we rely on identifying factors that are common for each term in the expression. The quadratic expression now will apply a little different techniques from common factor. The perfect square also will require different techniques. And difference of square, also a different technique. Now, it means that each of these techniques, the expression that we're going to apply these techniques to, you must be able to know which expression to apply which technique. So that is one of the key things when you're doing factorization, you have to be able to identify the expression and what technique to use. Now, the thing is with CSEC, they won't tell you what expression you have. You either know them or you don't know them. And if you don't know them, then you don't know what method to apply. So you have to learn the different expressions and know which technique to apply. All right, so we started off by looking at the common factor type expression. And so we say that if two or more terms have common factor or have factors which are common, these are called common factors, all right? Now, in this case, to factorize, we note the highest common factor. Now, the highest common factor here would mean that the highest, in terms of numbers, we would say the highest number that can divide into all the numbers if we have numbers right throughout all the terms. All right. We first place the common factor, then open the brackets. So first thing, you identify the common factor, then you open your brackets, then you divide each term in the expression by the common factor. Whatever you get in terms of the result, you put it back in the bracket. All right. So these are pretty much the steps. You keep the plus and minus signs as they are in the expression. The only way you will change these signs is if your common factor has a negative in front of it. All right. So looking at these examples, the first one here where we have 2x plus 6. I would have gone through these from previous class. So 2x plus 6. First, we identify factors that are common. Now, in terms of 2 and 6, what would be a common factor for 2 and 6 here? Miss Amanda. Which number can divide 2 as well as 6? Ms. Clark? Are you there?
Yes, sir, I'm here.
All right. Can you tell us which number you'd be able to divide 2 as well as 6 with?
1, sir.
All right. So 1 is a
Sir, 2.
All right, 2 as well. So I'm glad Miss Clark mentioned 1, because 1 can divide both of them, and 2 also can divide both of them. But when you think about the factor 1 and the factor 2, which of them is the highest? The 1 or the 2?
2, sir.
2, sir.
The 2, right. And that is why we are looking for the highest common factor. Reason why we choose the highest common factor is because once you use the highest common factor, you are able to completely factorize the expression without having any form of the expression that still remains to be factorized after you're finished. So you always look for the highest common factor, and sometimes students make the mistake of using the lower common factor, and when they do that, they still have some common factor remaining in the answer, which we don't want. So you always look for the highest common factor. For the numbers here, 2 is the highest common factor. So we identify our common factor, write it down, then we open our brackets. We divide each of these by the common factor. The 2 cancel out, leaving x, so we put the x in the bracket. Then we put back the plus sign. Now we divide the next term, which is the 6, by the common factor 2. 2 into itself goes 1. 2 into 6 goes 3. And so we put that 3 in the bracket. And then we close the bracket, and then our factorization will be completed after we close the brackets. All right, so that's basically what we're doing when we're doing the HCF method. All right, looking at the other one, question 2, where we have 5x squared minus 10x. So what is common in terms of the number? We want to look what for a number that can divide 5 as well as 10. The highest number that can go into 5 and 10 would be what?
5, sir.
Right, so our common factor, or our HCF, highest common factor, would be 5, because remember, 1 can also divide 5 and 1 can also divide 10. So the highest one is 5. So we position our highest common factor, open our brackets, divide each term by the HCF. Let me backtrack here, because I think we still have another common factor that we didn't mention. When you look at the letters, you notice that the x's are common. And so for the letters, what we want in terms of the highest common factor for the letters, we choose the one with the lowest power. All right. So in this case, even though we have an x squared and we have x to the power 1, for our common factor, we're going to choose the one with the lowest power of x. All right, and so we have 5x. So our common factor for this expression would be 5x. So we put our 5x in position, open our bracket, then we divide each of these terms by the 5x. And 5 cancel out with 5. X with x squared. If you cancel x to the power 1 with x to the power 2, all we're doing, we're subtracting the smaller power from the larger power and put back what remains. If you take away 1 from 2, we're going to have a power 1. So once this cancels out, we're going to have x to the power 1 remaining here, right? So in this bracket, we put back x. And then now we keep the minus sign from the expression. We divide 10x by 5x. And we see where 5 into itself goes 1, 5 into 10 goes 2. X into itself goes 1, and x into itself up here goes 1. So all that we have remain in the numerator is 2. So we put 2 in the bracket here, then we close our brackets. Now, the key thing with factorization, whatever you get after you factorize, you should be able to expand it. You should be able to multiply it back out and get what you started off with. So if you take the 5x and multiply what is in the bracket, you should get back the expression that you factorize. So you would have 5x times x give you 5x squared minus 5x times 2. 5 2 is 10, you will get back 10x. So that's one quick way to check if your factors are correct. All right. Now, as I said, we would have done these from the previous class. And because we are using the HCF method, then we are going through some exercises in how to find HCF. And we say in order to find HCF, especially for the letters, what we do, we choose the lowest power of each factor, which is common to all expression. And we would have gone through this from previous class. And if we have these terms, and we say find the HCF for these terms in terms of letter, Can anybody remind us how to go about finding the HCF for these terms? Ms. Clark, you remember?
I was in that class, sir.
Oh, you were not here. Ms. Cabrera, you remember how to find the HCF for these?
Yes.
Go ahead, Ms. Cabrera. Tell us how you find the HCF here.
All right, so first you're going to choose the number where everything is common in, and the lowest one would be AB 2 C square.
All right, so
AB square C
Ms.
square.
Cabrera, first and foremost, go through and identify the letters that are common to all of the terms.
ABC.
This expression, what is common in terms of letter?
ABC.
ABC. So in all the terms, ABC are common. Now, in order to choose for our HCF, each of the common letters, we're going to choose the lowest power of each of those. So for A, the lowest power of A for all three would be what?
A alone, sir.
All right, so this A would be the lowest power. So we pick that out. Do the same thing for B. What's the lowest power for B in all three of them?
The
B.
2, sir. B2.
A raised to the power 2. So we're going to pick that out and group that with the A that we already chosen.
Sir, you can go again, please.
All right, so I was saying, in order to find the HCF for letters in terms, you first have to look at all the terms. This is one term. This is another term. The terms are separated by the commas. And we want to find the HCF of all of these terms, the highest common factor. So we say first and foremost, you need to look to see that